Okay, hi there. Here we are all back and together again for our first ever virtual roadshow for SAQCC 1475. At the moment it looks like there could possibly be about 3 virtual roadshows coming up. In this roadshow, we have divided it into 3 sections. The very first section is a review of the Department of Employment and Labour's exemption on CO2 fire extinguishers. And that exemption is as defined by the SANS 1567. 1567, as you already know, is about CO2s. The second session is going to go on to and review tolerances, tears, and gross mass. Now, if you're anything again like me, this is something that gets very confusing, and it seems to confuse everybody in the industry. But I know that by the time we finish this session, you're going to be an absolute expert on tolerances, tears, and gross masses. And then, to make it a little bit more fun, we're going to end up with a quiz on record keeping. Now, this quiz is already something that you know. You're going to be able to share and check the answers with your friends, but I'm going to give it to you as a rapid fire thing. You're not even going to have time to ask your friends for answers. You're going to have to be pretty quick yourself. So in that session, we're going to find out just how good you are. So let us kick off with our first section, Section A, which is about the concession that the Department of Employment and Labour have given regarding CO2s. Certain aspects about CO2s came about that complicated the CO2s, particularly when they came to the pressure test stations, and people wanted to condemn the CO2s. A concession was required, a mandate, or a concession if you want to call it, was provided for those CO2s. Now, instead of me giving you a full rundown on the concession, who better to ask than Liesl Darfel? Liesl, who is the current chairperson of the 1475 committee, has been working with the Department of Employment and Labour, so she is very up on how this concession came about, why it came about. Just a bit of useless information as well. Liesl has also been very involved in the QCTO, which encompasses training for all of you, the technicians. That's going to be the next big thing with the SAQCC, but that's for another roadshow anyway. Let's hear from Liesl.
Thank you, Duncan. So going back to 2016, it was brought to our attention at the SAQCC Fire that there were non-compliant imported mild steel CO2 extinguishers in the South African market. After research, the SAQCC Fire then decided to request the then Department of Labour for an exemption on these CO2 extinguishers. After due consideration, the Chief Inspector then issued an exemption in December 2016 as per the Occupational Health and Safety Act. Now, as the pressure equipment regulations were only published in October 2009, this exemption then stated that all units imported between October 2009 and December 2016 had to be pressure tested within 5 years of the date of manufacturing. This meant that the owners of such equipment had 5 years within which they could then submit such a unit to a gas test station. Should the unit pass the pressure test, it could be kept in service. If it failed, it had to be removed from service. The Department of Employment and Labour issued a revised exemption in December 2019. It basically stated the same. Thus, mild steel CO2 imported units had to be pressure tested within 5 years of a date of manufacturing. But more importantly, it stated that this exemption will expire in December 2020. And any unit that has not successfully undergone such pressure testing shall be deemed non-compliant and shall be removed from service. Thus, the SAQCC Fire confirms to all registered persons that as you now have to service a mild steel CO2 extinguisher, you have to ensure that it has been passed by a gas test station approved by SANAS in accordance with the pressure test station 5 years within its manufacturing date. Specifically look out for pressure testing between 2016 and 2020. The reason for that is because it only came to our attention at the end of 2016, and the information was only distributed to the gas test station thereafter. Did they understand the requirements and specifically to look out for the incomplete manufacturing design specification BS 5045? Therefore, if you should come across a mild steel CO2 extinguisher that has not been pressure tested within this requirement, you have to remove it, take it to a gas test station, and let them go through the proper process as per the pressure equipment regulations and SANS 1825 to condemn such an extinguisher. This gas test station shall then issue a test certificate stating the unit has been failed, and this test certificate must be handed over to the owner. Be aware that if you or the 1475 company you work for condemn this unit yourselves, you will be in contravention of the pressure equipment regulations. We have also published this information on our website under the section News. So should you need more support when you approach your client regarding such a condemned unit, you can either request the client to access our website, or you can download and print the hard copy and hand it over to the client. If you have any further questions, you're welcome to approach us at our offices. You're welcome to approach me as well as Chair. Thank you very much.
Wow. Okay, thanks, Liesel. Gee, I was going to sum up what Liesel had to say, but I don't think I need to. I think she was very, very succinct in how she put an explanation of that concession forward. If you have any concerns still, please go onto the SAQCC website. You will find an explanation there. Liesel, thank you. All right, let's go on to section B. And section B is that fun part about tolerances, tear weight, and gross weight. And as I have already mentioned, this is the section that for some reason confuses everybody. And it was actually only yesterday when the person, and I'm going to present him now, who came to speak to us, and he's going to fill us in on how they work, that I, for the first time, actually understood the difference, the real difference in fire extinguishers between tears and gross weight. And who better to ask us to explain this than Tim de Bruin? So now, everybody, really good time. Get the pen out, get the paper out, get the calculator ready. Tim, it's all over to you.
Right, hello guys. Duncan, thank you for the introduction. We're going to be discussing charge, empty mass, tear mass, gross mass, and tolerance. To get started, let's look at the terminology that we use in fire equipment. So as you can see the diagram here, this is a fire extinguisher. What we put inside the fire extinguisher is called charge. It is the total that is inside the extinguisher. If it's a CO2, it's CO2 inside there. If it's a dry powder extinguisher, it's the dry powder that goes inside the extinguisher plus the nitrogen or the CO2 that you use as an expellant. So it's everything inside the extinguisher is called charge. If we talk about empty mass or tear mass, now using a fire extinguisher like a CO2, We know it's an extremely high pressure extinguisher. You cannot trust the label. You don't take the information from the label itself. The information that you require to service a CO2 fire extinguisher will come from the shoulder of the cylinder. And having said that, the shoulder of the cylinder is always accurate. Now, the tear mass on a CO2 extinguisher is the mass of the extinguisher as it is going to be when it is ready to be recharged. You cannot recharge this extinguisher without the valve because there's nothing going to hold the CO2 inside it. So a CO2 fire extinguisher tear mass is empty with a cylinder and the valve included. And as you see it now with nothing inside, that is its tear mass. If we talk about a low pressure unit like your dry powder, your water, your foam and your wet chemical, you don't have a tear mass. The tear mass, in fact, would be with everything off. But for this session, we talk about the empty mass of the extinguisher. So if we have a look at the tear mass, we're talking about a CO2. The empty mass, we're talking about the other units, which are low pressure units. And the empty mass you can either get from your scale or it is clearly printed on the instruction label of the extinguisher itself. We're talking about gross mass. Now, gross mass is the total mass of the cylinder with the valve, with a discharge hose, or in the CO2, a discharge hose and horn. It includes the service label. It includes the sealing tie. It includes absolutely everything in the state that the extinguisher would be when it is delivered back to the client after full service. And that is called your gross mass or your full gross mass or total mass of the cylinder or the extinguisher. Right, we're going to move on to tolerance. Now we know the terminology that we use. The tolerance of an extinguisher. So the charge of this extinguisher, for example, is 5 kgs. What that means, it's called a 5 kg CO2. 5 kgs is what goes inside the CO2 extinguisher, and we should have 5 kilograms of CO2 inside here. But it is not always possible to recharge this to exactly 5 kilograms. Sometimes it's a little bit over, sometimes it's a little bit under. And because of that, there is an allowance. You are allowed to go slightly over, you're allowed to go slightly under, and that's called tolerance. If we have a look at a fire extinguisher, the charge of the extinguisher is accurately where we want it to be. So in the case of this particular extinguisher, it is 5 kgs. So the charge that we want is shown by this line here, where we have charge at the bottom. In the instance of a powder, water, or foam of this size, it is 9 kgs or 9 liters. So let's work with this one here. If the charge that I want is 9 liters or 9 kgs, and I overcharge that by accident, it's okay as long as it's not too much. Okay, so if we have a look at the diagram that we have on the board, this shows you that fire extinguisher there, which is a 9 kg or a 9 liter. The charge that we want is 9 liters or 9 kilograms. If we go overcharge and we go slightly overcharged, it is not a problem if that is the level of the charge inside here, because you are permitted to go slightly over. If you go slightly under, it is not a problem as long as you are within tolerance. Now that tolerance amount is 5%. It's 5% of the charge of the extinguisher. If you go lower than 5%, your extinguisher will not function as it's meant to. It will not put out the fire of the size that it is placed there to put out. If you go overcharged, no, it's not better. It is definitely not a good thing to overcharge, because this space at the top here, which is called ullage, is reserved for your nitrogen or your CO2 to go in there, which is now your expellant or your propellant. If there is not enough space here, you cannot put enough gas in there, and there is not enough power to push all of the charge out. So when you operate an overcharged extinguisher, you're not going to discharge all of its extinguishing medium. Too much charge is a bad thing. Too little charge is a bad thing. So we have a look at what we are allowed. We are allowed 5% overcharged, and we're allowed 5% undercharge, and that fire extinguisher will still function as it was intended. So the information that is required before you can calculate any of this is the charge. So if we work with this extinguisher here, we know the charge of this extinguisher is 9 litre or 9 kg. How do we know? Well, someone with experience can look at it and you can tell the size. If you're unsure, refer to the instruction label. So we know the charge is 9 kilograms. So if we have a look at using a 9 kg DCP fire extinguisher, let's work out if the charge inside here is sufficient, or if it's underweight, or if it's overweight. So we know the charge of this extinguisher is 9 kilograms. We now need to look at the empty mass. Don't forget, tear mass, CO2, empty mass, powder, water, foam, and wet chemical. So where do we get the empty mass from this cylinder? We need to look on the instruction label. The empty mass on the label is 3.45 kilograms. So we know this fire extinguisher, if I sprayed everything out, will weigh 3.45 kilograms. So if I take my 9 kgs charge, which should be in here, and I add 3.45 kilograms, I will get 12.45 kilograms. Which, if this extinguisher was recharged totally accurately, it should weigh. The weight is 12.34. So the actual weight of this extinguisher is 12.34. Now what does that mean? That means that it is not 100% accurately filled with 9 kilograms of powder. But is that a problem? We don't know yet. The 12.34 that it weighs now is less than 12.45. But if it is within this tolerance band, that extinguisher is still okay. If it is lower than this tolerance band or higher, then we need to either discharge or remove some of that charge and correct it. So let's have a look at how do we calculate this. Our charge is 9. To go higher than the charge, we're going to add 5%. So if we go to our calculators and we go 9 plus 5%, the answer we will get is 9.45. That 9.45 is the maximum amount of charge that we are allowed to put inside that extinguisher, and it takes us up to this green line. Anything more than that, it's a problem. If we are undercharged, which is the case with this fire extinguisher now, it is not a problem as long as it is within the 5% tolerance. So the undercharge, we go 9 minus 5%. And the answer we get on our calculator, 8.55. So it's quite clear the charge inside the fire extinguisher may be 9.45 to 8.55, anywhere in between that. How do we test this? Well, we can't take the powder and put it on the scale. We take the powder with the extinguisher, with everything, and put that on the scale. Everything excluding the powder means it is empty mass. How do we add our empty mass to this? Well, we know what it is. So we now need to add our empty mass of 3.45, and we need to add it to the minimum charge. So 9.45 plus 3.45 gives us 12.9 kilograms. 8.55 plus 3.45 equals 12. So in summary, what we wanted to achieve is 12.45. When we put the extinguisher on the scale, we got 12.34, which is slightly underweight. But is it acceptable? Yes, because it is within that tolerance band of 12 and 12.9. The actual mass of 12.34 sits between the minimum and the maximum. This fire extinguisher is perfectly charged. Right, so according to our formula and our calculations, this fire extinguisher is perfectly within tolerance. There is nothing wrong with the charge, and it is good to go. What we need to do now to finish it off is we put our service label on, we put our anti-tamper or our sealing tie on, we put it back on the scale, and we look at our full gross mass, which is our total mass. And if we have a look there, it's 12.34, and our total mass, 12.34. On our job card in our workshop, it is important for us to know how much powder is inside this extinguisher. Okay, so to work out our charge, we take our 12.34 minus 3.45 equals 8.89, and that means we have 8.89 kilograms of powder inside that fire extinguisher. Right, let's move on from our low pressure units, where don't forget our low pressure units, we used our empty mass. We move on to our high pressure units, where we will use our tear mass. All right, guys, we've finished with the low pressure units. We're now going to move on to the high pressure units. High pressure units being CO2. So if we have a look at a CO2 fire extinguisher, the information that we require before we can do a service, two things. The charge, so we know the charge of this extinguisher because either you have got experience and you can identify it, or, now we don't look at the service or the instruction label of this unit, we look at the stampings, the markings on the shoulder of a CO2, and on the shoulder it will say 5 kg CO2. So this unit is a 5 kg CO2. Because we're working with a high pressure unit, we're working with a tear mass. The tear mass is the cylinder and the valve, excluding the hose and horn. So we remove the hose and horn. And the markings on the shoulder of the extinguisher, we read these and we get to tear mass. So in this instance here, the tear mass of this extinguisher, 8.38 kilograms. 8.38. Right, so we're not working with an empty mass, we're now working with a tear mass. So our tolerance calculation is now charge, 5 kg CO2 plus 5%, is 5.25. Charge of 5 minus 5% tolerance, 4.75. So what we put on the scale is the cylinder with the valve and the charge. So on our tolerance calculation, we have to have the cylinder with the valve with the charge. So 5.25 plus 8.38 is 13.63. That's the maximum that the cylinder should weigh. And the minimum is 13.13. Our calculation is complete. Now we're going to go and verify if there is sufficient charge inside this cylinder. So we put it on the scale, we get 10.96. That is the minimum, that is the maximum. For this extinguisher to be correctly charged, it must be between the minimum and the maximum. However, at 10.96, it is below the minimum charge and below the minimum 5% tolerance. This extinguisher is underweight. As we know in terms of the SANS codes of practice, we may not top the CO2 up, so it gets discharged completely, sent for full recharge. Just for interest's sake, let's have a look at how much CO2 is inside here. So we take the actual mass that we got from the scale, 10.96 minus 8.38. So we have our actual mass, 10.96. We remove the tear, and the charge inside this extinguisher is 2.58. So we've worked out inside here 2.58. We know it is undercharged. We're going to empty it completely and send it for a full recharge. So just in summary, things that you need to remember: if we're working with the low pressure units, we're using empty mass. If we're working with the high pressure units, we're using tear mass, and that tear mass is written on the shoulder of the extinguisher. And we have to be able to work out our tolerance on the charge before we can determine whether the extinguisher is empty or full. Thank you for your time. Thank you, Duncan.
Yay, Tim. Okay. So, we've learned the meaning of charge, of tear weight, of empty weight, of gross weight, and we understand the tolerances that are permitted within a fire extinguisher. You remember what they are? 10% over, 10% under? 5% over, 5% under. I knew that you knew that anyway. I was just checking. I've got a little quote here from SANS 1475 Part 1, because this is also quite important, and I remember Tim telling you about this, that a powder, a CO2 or foam extinguisher shall not be topped up if more than 5% undercharged, but shall be emptied and fully charged. Once again, I know all of you remember that, but remember that other people don't remember it. Tim, a massive big thanks from us. I'm sure that we're going to be hearing from you again. Thanks, Tim. Here we are to the last section, and as I promised you, we were going to have a little bit of fun. We're going to have rapid fire questions. You need to have your pen, you need to have your paper ready. The rapid fire questions are going to be on record keeping. I know that you already know the answers, so you don't have to worry about that. It's how quickly you can recall them and put them down on a piece of paper. And I'm going to sort of only just give you enough time, so you might even need to abbreviate what you're putting down on the paper. You ready? You got your pen? You haven't got a pen there? You need some paper. Okay. I think we're all ready. Question 1. What documentation may be issued to confirm completion of a service? Question 2. In addition to providing the required label, the customer needs to be provided with a record that includes at least 7 pieces of information. I need those 7 pieces of information. Question 3. How are you going? All right? Great. What information may you not supply for record keeping? What information may you not supply for record keeping? Question 4. Does a fire extinguisher have a lifespan? Say that again. Does a fire extinguisher have a lifespan? Now we're getting on to a little bit more tricky. We're going to talk about the mediums inside the fire extinguisher. Or you might remember Tim talking about it as a charge. Okay, if you know it as medium, you know it as charge, it's what goes inside the fire. That's what I'm wanting to know. What is the maximum lifespan of a fire extinguisher medium for the following mediums? First one, powder. Second one, CO2. Third one, water. Fourth one, foam. Fifth one, wet chemical. You got those lifespans? You've read 1475 Part 1 and Part 2. I know that you have, so you know it already. Question number 6. Quite a tricky question. What is the permissible number of fire extinguishers that may be removed from a floor at any one time while servicing on site? The last question, question number 7. If extinguishers have to be removed from a site completely, what is the maximum percentage that may be removed? If extinguishers have to be removed from a site, what is the maximum percentage that can be removed? Here we go. Let's have a look at the answers. I'm going to go through these fairly quickly. The first one, what documentation may be issued to confirm completion of a service? A certificate of service. If you want to argue the question, send the argument in SAQCC Fire, and you can mark it attention Rosemary. Right, in addition to providing the required label, the customer needs to be provided with a record that contains at least 7 other pieces of information. What are they? First one, customer name. You can have it in any order, by the way. Customer name, date and type of service, date of recharging, date of pressure testing, next service due date, size and type of extinguisher, location of the extinguisher. Next one, what information may you not supply? We cannot issue a document indicating that the premises are in compliance with the building regulations or the local bylaws. Question 4, Does a fire extinguisher have a lifespan? Well, this is quite an interesting one. In the rest of the world, a fire extinguisher has a lifespan. South Africa, it has no lifespan. The answer is no, it does not have a lifespan. Question 5. What is the maximum lifespan of a fire extinguisher medium? As I've stated, I'm pretty sure most people not going to get all this right. The first one was powder, 10 years. Second one, CO2, 10 years. Third one, water, 5 years. Fourth one, foam, 5 years. And the last one, wet chemical, 5 years. Question number 6. The question was, what is the permissible number of fire extinguishers that may be removed from a floor at any one time while servicing on site? Permissible number, 50%. But the standards do say that the balance of the fire extinguishers have got to be distributed evenly around that floor. Question number 7, the last question. If extinguishers have to be removed from site completely, they're going to a workshop, what is the maximum percentage that can be removed? Maximum percentage, 25%. Well, here we are. We've come to the end of our very first virtual roadshow for SAQCC 1475. And trust me, it's been a great experience and it's been great sharing it with you. And a huge thanks to all of you for joining us. It truly has been great fun. If any of you have any questions that you would like, and I know in a normal roadshow we would have question and answers. Unfortunately, it's not that easy at the moment, but if you have any questions that you would like, please forward them to the SAQCC Fire, and I will ensure that somebody answers your question as soon as possible. Thanks for being with us today.